Hello friends, welcome to my channel Scientist Words. I'm your friend Ashwin. Today we're going to talk about stellar life cycles, the epic birth, life and death of stars revealed through this video. Welcome stargazers. Today we are embarking on an epic journey through the life cycles of stars. These cosmic beacons aren't just twinkling lights in the night sky. They are the engines of the universe, forging the elements they make up everything from planets to your own body. From humble beginnings in vast clouds of gas and dust to spectacular deaths in explosive supernovae, the story of stars is one of the constant transformation and cosmic recycling. So let's blast off into the stellar nurseries and witness the birth, life, and the death of these celestial giants. Our journey begins in the stellar nurseries, vast clouds of gas and dust called molecular clouds or nebulae. These cosmic incubators can span hundreds of light years and contain enough material to make millions of stars. When a part of the cloud becomes denser, perhaps triggered by a nearby supernova shock wave, gravity takes over. The cloud begins to collapse and fragment, forming pockets of even denser material. As these pockets contract, they heat up, eventually forming protostars. It's like watching cosmic dust bunnies come together to ignite miniature suns. This process can take millions of years, but in cosmic terms is just the blink of an eye. Once a protostar accumulates enough mass and its core reaches about 10 million degrees Celsius, hydrogen fusion kicks in. This marks the birth of a true star and the beginning of its main sequence life. Our Sun is a main sequence star, steadily fusing hydrogen into helium in its core. This process creates an outward pressure that balances the inward pull of gravity, keeping the star stable for billions of years. Stars come in different sizes and colors, from cool red dwarf to hot blue giants, all plotted on the famous Hertzsprung-Russell diagram. It's like a stellar family portrait showing the diverse range of stars in our galaxy. Stars don't stay the same forever. When a star like our Sun runs out of oxygen in its core, it begins to fuse helium, causing it to expand into a red giant. This phase can be quite dramatic. Our Sun will eventually grow so large it might engulf Mercury and Venus. For stars up to about 8 times the mass of Sun, the next step is to shed their outer layers, creating beautiful planetary nebulae. The exposed core, no longer able to sustain fusion, becomes a white dwarf, a hot, dense ember slowly cooling in space. It's like watching a cosmic light show with stars painting the galaxy with colorful nebulae as they enter their twilight years. For stars more than about 8 times the mass of Sun, the end is much more dramatic. These cosmic heavyweights can fuse elements all the way up to iron in their cores. But iron fusion consumes energy rather than producing it, leading to a catastrophic core collapse. The result is supernova, an explosion so bright it can outshine an entire galaxy. Supernova are cosmic forges, creating and scattering heavy elements across space. In fact, every atom in your body heavier than iron was likely created in a supernova explosion. It's a reminder that we are quite literally made of star stuff. What is left after a supernova? For stars between about 8 and 20 solar masses, the core collapses into a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons on Earth. Some neutron stars spin rapidly, beaming radiation from their poles. We call these pulsars. Even more extreme are magnetars, neutron stars with incredibly powerful magnetic fields. For the most massive stars, not even neutron degeneracy pressure can stop the collapse, and a black hole is born. It's like nature's way of pushing matter to its absolute limits, creating objects that challenge our understanding of physics. The death of stars isn't the end of the story, it's just part of a grand cosmic cycle. The material ejected by a planetary nebulae and scattered by a supernova encircles the interstellar medium with heavy elements. This enriched gas and dust will eventually form new molecular clouds, giving birth to new generation of stars and planets. Each generation of stars contain more heavy elements than the last. It's like beautiful cosmic recycling program that has been running for billions of years. The iron in your blood and the calcium in your bones were forged in long dead stars. And there you have it, the epic saga of stellar evolution, from birth in cosmic nurseries to spectacular deaths and cosmic recycling. Stars are the engines that drive the evolution of the universe. They create the elements necessary for planets and life, scattering them across the cosmos in their death throes. Every time you look up at the night sky, you are seeing stellar life cycles in action, from young, hot stars in the Orion Nebula to that dying red giant Betelgeuse. And remember, the atoms in your body has been through these cosmic cycles, perhaps many times over. We are, in the most literal sense, children of the stars. So the next time someone says you are not a star, you can tell them that actually you are made of star stuff. And that's pretty amazing, right? Thank you very much for watching this video. I hope you enjoyed exploring stellar life cycles, the epic birth, life and death of stars revealed through this video. Stars shape the universe from dazzling beginnings to spectacular endings. Keep looking up and stay curious about the cosmos. Thanks again for watching this video. I hope I see you in my next video. Thanks again for watching. Bye bye.